Hello everyone and welcome back to Art of Code. Today we are on day 6, which is called Trash Compactor. It goes like this. After helping the elves in the kitchen, you were taking a break and helping them reenact a movie scene when you were over enthusiastically jumped into the garbage chute. A brief fall later, you find yourself in a garbage smasher. Unfortunately, the door has been magnetically sealed. As you try to find a way out, you are approached by a family of cephalopods. They're pretty sure they can get the door open, but it will take some time. While you wait, they're curious if you can help the youngest cephalopod with her math homework. Cephalopod math doesn't look that different from normal math. The math worksheet, which is our puzzle input, consists of a list of problems. Each problem has a group of numbers that need to be either added or multiplied together. However, the problems are arranged a little strangely. They seem to be presented next to each other in a very long horizontal list. For example, here is a showcase of our puzzle input in a much smaller scale, but basically it goes like this. Each problem's numbers are arranged vertically. At the bottom of the problem is a symbol for the operation that needs to be performed. Problems are separated by a full column of only spaces. The left/right alignment of numbers within each problem can be ignored. So this worksheet contains 4 problems. 123 times 45 times 6, which gives 33,210, 328 plus 64 plus 98, which is 490, and so on and so on. Basically, we are looking at the columns that are separated by a single space and nothing else. To check their work, cephalopod students are given the grand total of adding together all of the answers to the individual problems. In this worksheet, the grand total is 4,277,556. Of course, the actual worksheet is much wider. You'll need to make sure to unroll it completely so that you can read the problems clearly. Solve the problems on the math worksheet. What is the grand total found by adding together all of the answers to the individual problems? So, today's task is part 1 is extremely simple. The only problem is on how we can parse this input. And this is one of those tasks where parsing the input is the hardest part. So let's see how that would look like. Of course, we will start by opening our file with open example as f. And now we will go through our worksheet. I will create a for loop that will go through the file. And now we will go through each of the lines and we will store them in a worksheet. In a worksheet that will be an empty array to which we will be appending those lines. Of course, we want to we will be stripping each line because as we know in Python when we are reading, all the lines get the /n at the end of themselves. So we can see that by doing print line. Like this I won't actually be able to see it sadly, but maybe if I actually append it, worksheet.append line, and then if I actually print the worksheet, yes. So we can see we have here this /n, but what we can do is to strip that /n, and now we have this. Okay, now once we had that visualization, I will create a function that will hold our logic for part 1. We'll go def part 1, since naming isn't my strongest suit, and we will pass in a worksheet. Since we need to get a total of all of the math problems, I will just create a total 1 equals to part 1 return value of the part 1. So yeah, now what we need to do is the following. For now I'll just do return 0 so we don't get any errors. What is this? Part is not defined. Okay. So what we need to do, we will first, we need to get our numbers with which we can work, so we can actually get some data to work to properly transform into the necessary columns that we can then use. Since it's easier for us to read from left to right and not from top to bottom in programming, we will create a small function as we go on that will do that for us. That will basically sort of rotate our array. So now let's first get some numbers that we can actually use. I'll create a normalized worksheet variable where we will call a problem for problem in worksheet. Since we are calling our function here, let's see how that would look like. Print normalized worksheet. And now we get all of these numbers. We can first start by stripping any unnecessary spaces. And then we will just split so we can get our numbers. So what do we do now? Now, if we would go row by row, actually maybe it would be easier if I do normalized worksheets, print R. We will do it like this. So now we need to get the column, we need to group up our columns since we have our rows. And we can do that by, and since this is a 2D array, normalized worksheets is a 2D array, we can apply a certain trick that you usually find in maths when doing matrices, and that's called matrix transpose, my bad. And in Python, that basically looks like this. I will just name these problems, and we will return a list, and we will now and we will use a zip that will handle that for us. We can use a zip here because what zip actually does is, let's say for example we have, I'm just gonna be using things like this, 3, 4. Let's say we have values like 1, 2, and 3, and 4, and this is all in our random array. Now, if we would apply a zip to this array, what zip would do is basically take the first item from every array and group them together. Then it will take a second item from every array and group them together, take the third item from every array, group them together, and so on and so on. So that's why zip here is a lifesaver for us, because it basically does half of our job. So if we would print transpose normalized worksheet, we would now see that we have our data, or well, our numbers that we needed to have grouped together, like 1, 2, 3, 4, 5, 6, and multiplication in a single so-called line that we can work with. Now, literally all that is left to do is to actually calculate all of those problems together, and we will create a variable called total that will hold the sum of those problems. So in order for us to get a numbers and operation, since we know that in our transposed matrix in this case, or a worksheet, we have seen operation was at the end and everything else was before. This literally just tells to Python, hey, spread everything, every element, like so, from numbers, and then get the last element into its own variable. So if we have 1, 2, 3, 4, and a star, and a star, what did I do? I again changed something. Let me just fix that quickly. Okay, our nums will basically hold 1, 2, 3, and 4, and our, again the same mistake, and our OP will basically be equal to a star. So now the rest is trivial, and in this case, what really helps a lot is a eval, which evaluates strings as programs. So in this case, what we will do, we will use a join on the operation with the numbers. What does that do? Is basically, if we have 1, 2, 3, 4 of the numbers, if we would join them with an operation, which for example, let's say is a multiplication, if we would get a string that would basically be 1 times 2 times 3 times 4, and eval actually will evaluate that string. As it says here, evaluate the given source in the context of globals and locals. And now we can just return our total, and let's print part 1, total 1, and we get this number, which is the correct answer as showcased on the Advent of Code website. And if we would run it on our own input, we would get this extremely large number that is the correct answer. Now let's start off with a part 2. The big cephalopods come back to check on how things are going. When they see that your grand total doesn't match the one expected by the worksheet, they realize they forgot to explain how to read the cephalopod math. Cephalopod math is written right to left in columns. Each number is given in its own column, with the most significant digit at the top and the least significant digit at the bottom. Problems are still separated with a column consisting only of spaces, and the symbol at the bottom of the problem is still the operator to use. Here's the example worksheet again. Reading the problems right to left, one column at a time, the problems are now quite different. The rightmost problem is now 4 plus 431 plus 623, which equals to 1058. So we are expected to do the following. As we are reading our columns, we can check that there is this empty space here that corresponds to absolutely nothing. And so that's where these 4 correspond to absolutely nothing. But this column of this group has a 4 at this spot, so that's where this 4 comes from. 431 is basically on a second column, which corresponds to these numbers 4, 3, and 1, and 623 is from the first column. To now check it with a first example, which is much more elaborate. For example, we have 123, 45, and 6 as our numbers, but the columns we need to get by following the logic would be 356, 24, and 1, which in this example is 356 times 24 times 1 equal to 8,544. Solve the problems on the math worksheet again. What is the grand total found by adding together all of the answers to the individual problems? Now this one starts to become a bit more complicated because our initial logic from part 1 won't work as well as it will for part 2. So let's slowly begin by creating a function called def part2 so we can have something. It will also accept a worksheet. We'll just type in a return 0 for now, so we don't have to worry. Do total underscore 2 equals part2 to worksheet. Now I will just comment this out so we aren't confused as I'm going through the code. Now let's print our worksheet and see how it actually looks like. Oops, I'm using my input, which is not unreadable at that state. Okay, so here now our worksheet looks something like this. We want to again basically do the same thing. So in this case, the easiest solution would be to immediately transpose the worksheet and then work with it, because what that will give us is numbers like so. Now we have immediately like 1, 24, 356, then this is all empty. This corresponds to all of those empty spaces, like the separators of the columns. Then we have, what is this? 369, 248, then we have 8, again the empty, and so on and so on. So that's why, in this case, immediately transposing the worksheet works better than doing what we did before by splitting the numbers individually and then transposing them. So we will do normalized worksheet, and it will be equal to transpose of the worksheet. Now what we want to do, since we know that we have those empty columns, we want to basically group all of these individual groups, I would call them, sure, individual groups, and skip or stop constructing a group when we reach this one, and then start constructing a new group. Then again, if we reach all empty, stop, then do this, etc., etc. So let's start by creating a function. Since naming is again the hardest part, we will just call it, I guess, a group up that will accept a worksheet. In this case, we will pass it a normalized worksheet, and we will create a empty variable called groups that will hold all of our groups that we have constructed, and we will have a variable called current group that will equal to the also empty array that will hold all the necessary ones, that will hold all the current numbers up to a breaking point, which is gonna be this whole empty group. So we'll start for a problem inside a worksheet, and now what we can check is we will create a set of we will check by a set of each problem, and we will check if the length of the set is equal to 1. We can do that since it is always guaranteed that for the non-empty columns that they will contain a number or an empty string and an empty string, or not an empty string, but at least there will always be at least 2 elements, while if it's all empty it will equal to 1. So what we can do is basically check if a length of a set problem is equal to 1. If so, we can append our current group to our main groups, and then we can just reset the current group. Else, we just do current group is equals to append equals to a problem. One final thing we need to do is, since at the end we don't have a empty column, our current group that gets filled at the end, which is gonna be 623, 431, and 4, won't get appended. So we have to do it manually, and we just do groups.append of a current group, and we return those groups. And that's basically it. What we can now do is create a new variable called group_problems equals group_up and normalized worksheet. And now let me just do for r in group_problems print r, so we can see how that looks like. And now we have them here. We have 1, 24, 356, 369, 248, 8, and 623, 431, and 4. This all corresponds correctly and is nicely placed for us to do our magic, to do our operations. And one thing we can immediately notice is that each of these columns at the end of all the groups will be either empty or will have an operation, so we can immediately get our operation from the end of the first group. So we can just do operation equals to a group. Oh, my bad. Let me just remove this for group in group.problems. Operation will equal to a group. We will take it from the first one and we will get the last element, which in Python we can easily do by using a negative index. This just means get the last element, -1. Now what we need to do is sort of group up our numbers so we can start working on them. And now how would all those numbers look specifically for each group? We can showcase again that by using a for loop, so we can get a better insight of how that would look like. Print nums. Okay. Yes, I decided to since we know our last column inside each of the groups is an operation or an empty string, we can not empty string, empty space, we can just ignore the last element and spread all of the other ones. And now we have our groups like so. So now we know what we are working with. What we can do is we want to also join all of these numbers because we want to join specific ones inside each group, so we know, so we get something like I don't know, in this case it will be 1, 24, 356, and then so we can again just join them with an operation. And how would that look like? I'll just create a variable called all nums grouped. Again, naming might not make sense, but it's the best I can give. And we just do. We will join the numbers on nothing or an empty string for nums in nums, comma, last element ignored in a group. Oops, not in 4. And now we have all those nums grouped. And last thing we can do is total. Oh, we forgot to define a total variable that will hold our total. We can again do eval of op.join, and we will do all nums grouped. We just now return a total, and we have a total of 1. And now let's do a 2. And as we can see, what did I do wrong? Okay. And now we get a completely different answer for part 2, which is 3263827, which is the correct answer for the example. And if I would run this on my own, we would get this, again, an extremely large number. That is the correct answer for my input. So that's it. Pretty straightforward problem, I would say. Again, as I said, the only main issue was to parse the input, but after that everything is a walk in a park. So until tomorrow, I hope you guys have enjoyed this video and have learned something. As always, any feedback is appreciated. Take care and peace.